Hi, everyone. Welcome to the OCP Global Summit. This is a server track session. We're doing the virtual conference. I really appreciate this contribution and participation by everyone in the community to come together even in a virtual forum. So today I'm going to talk to you about Yosemite v3, which is a new platform for single socket server to be contributed to the OCP community by Facebook. My name is Ryan Emmett. I'm a technical program manager from Facebook, and I'll be joined later in this presentation by Kieran Vimuri, who's a hardware engineering lead of the platform. Yosemite v3, as a highlight, is a one-socket-based server platform that can handle up to 4 server nodes together, and it's an iteration, next generation from our last Yosemite v2 that we contributed with the Twin Lakes server card in our previous generation of single-socket compute. I wanted to start out just to introduce the single socket compute rack philosophy. Our single socket servers, and which Yosemite v3 is our next generation platform building block, are extremely efficient towards performance, cost, and power in terms of how Facebook infrastructure is using our hardware. We try to make sure that we can optimize and fit as much power into the rack that we can utilize from the single socket point of view. And we work with our CPU vendors to make sure that our CPU SKUs are customized for performance per watt as close as can be. And we also try to make sure that these can support up to a very dense topology of racks. Like in Yosemite v3, we can support up to 96 servers optimized around total cost of the system, as well as the rack topology that we can support. And the Yosemite v3 is also a modular platform design, which can enable accelerator flash configurations to be installed as part of expansion cards to the server so that we can support different compute only or compute and other system configs that can make sure other workloads can be possible as well. Now I'm just going to show you a few highlights of the Yosemite v3 sled design itself. So specifically here, we have the Medusa board at the back, which is start of the power architecture. There would be a Medusa cable that's not shown here that connects to the OpenRack v2 bus bar and then connects into the power distribution board from that point of view for distributing the power split between the baseboard and the 4 server cards that you could have in a system. So one server card is shown here, the Delta Lake motherboard, which is the lead vehicle for the platform design. And that has the CPU, the DIMMs, the storage cards, and we have the PCIe expansion connectors. This is a new part of the architecture here. Now the server card is the expansion to the accelerator cards through PCIe. So we could have a front expansion card or a riser expansion card that can be above the server card. And that's where you would plug in other expansion modules that could support the flash or accelerator use cases. We also have an I/O board in the front here, which is also for showing signals like repair actions needed or LEDs to the data center teams who would be able to see the front-facing server. On the baseboard side at the top is connected through this PCIe cable, CPU sled management cable that we have, which would basically bring the network PCIe signals as well as the management signals from the Delta Lake or any server card to the baseboard card. The baseboard then is responsible for the BMC management, and it would be the one that would connect through a shared NIC topology when we're doing our standard compute platforms where we have a shared NIC that's supporting 4 hosts underneath it. At the back here would be where we would have the fan assembly modules, not shown pictured, just to try to keep a clearer picture, but there's fan modules that would be able to have 2 different fan modules per sled as well. And just to call out that this sled is also slightly larger because we've also increased the thermal capabilities and the power capabilities of the sled to be able to manage for even higher workloads depending on what kind of acceleration or flash technologies we're investigating for the system configs that would use those. And I also wanted to show just what one complete compute-focused sled would look like here, where you can see we have 4 Delta Lake motherboards all connected in the same sled with the I/O cards of each sled server blade, and then to the baseboard that does the system management, and then the power architecture behind it. And this would be enclosed in a metal enclosure, fan modules in the back as well. Just to also call out that this is now a fully front-loaded server card. So it means you could take out a single server blade as a replaceable through unit for replacement as without taking the sled out of the power domain as well. We were also able to do a single server through in Yosemite v2, but in that design, you would pull out the whole sled and the twin lake cards were vertically inserted. Now they're horizontally on a flat plane and can be removed on their own without taking the sled out of the rack. I'm now going to pass the presentation over to Kieran, who will go over the modular design philosophy of the server and sled next. Thank you.
Thanks, Ryan. Hi, everyone. This is Kiran Memuri, hardware engineer at Facebook, leading the Yosemite v3 platform. This is a block diagram representation of the YV3 or Yosemite v3 sled that Ryan explained earlier. What you see is the connection between the shared NIC and the server boards through the baseboard. So all the 4 servers share the common NIC, and you see the PCIe ports are represented on the right as expansion options. On a normal compute configuration, which is the most common one, you would see just the 4 servers. Now, if you want to add a flash expansion option, it is pretty straightforward to add the expansion card with flash modules to arrive at a direct attached server system. And then if you want to make it a hardware accelerator system, you can add a whole bunch of hardware accelerators. And to accommodate the additional accelerators, 2 server boards would be removed to enable that. And let's say the accelerators require a dedicated NIC because they're pretty bandwidth intensive. So in that case, one of the expansion through the PCI lanes becomes connected to the dedicated NIC, and the other expansion becomes a bunch of accelerator modules interface. Now, if you want to add more accelerators, you could add a PCIe switch and enable that. Now, on the same platform, let's say a new CPU is available, and we want to design a new server board and add that into this sled. That is very much possible by enabling a new CPU board on the same platform. So that way, the whole Yosemite v3 is designed to be very modular to accommodate many configurations. This is a mechanical rendering of the sled with 4 servers and the baseboard that you see on the top. And this is the most commonly used config. Here is the flash-based storage with a bunch of M.2 flash drives connected to the server through the expansion board. This is the case where we are adding a bunch of accelerator modules. So we take away 2 servers and enable all the PCI lanes to be used. And this is the config where we are using a hardware accelerators that are very bandwidth intensive. So there's a dedicated NIC provided to each server. And there's also a PCI switch to support so many hardware accelerators. And the hardware accelerators could be anything like a video transcoder, or it could be a inference module for inference applications. You could attend the hardware accelerator session at the OCP Summit. Now, this is an actual working Yosemite v3 sled. You can see the baseboard on the top and the 4 servers. One of the servers is pulled out to show the server board, which is called Delta Lake. We have gone through 1 round of validation of this server platform. And at the moment, we are beginning to test it in the data center as well. For the call to action, we originally planned to have a face-to-face interaction with the OCP community at the summit, where we could demo the Yosemite v3 server. But since that's not possible now, the event is virtual. And please reach out if you need any more information. I would, if you're interested, there's the Delta Lake server board session and also hardware accelerator session at the virtual OCP Summit. You're welcome to join us for that. Thank you, everyone. If you have any questions, we are open
Hi all, this is Ryan Emmett here. Can you hear me? I hope you can. Hopefully you enjoyed the session on Yosemite v3. There was one question raised about, are the hardware accelerators using the Glacier point board? And I just wanted to say that the expansion cards for Yosemite v3 are newly designed from the Glacier point board that goes in Yosemite v2. There's new forms of expansion cards that we've designed for the Yosemite v3 Delta Lake connection. So those are similar in form and configurations as the Glacier point board, but it's a different board for the hardware accelerator use cases that could connect to Yosemite v3. There's a question also about, would it be possible to have a single server and greater than 4 accelerator cards? Technically, the expansion options for the Delta Lake has 2 different ports in the 1U space in the front and the 2U on top. Those are the 2 major connections off the Delta Lake card. So right now, most of the use cases are focused on 2 accelerator cards with a single server. And the sled configuration then is a 2U per server and 2 sleds with accelerator cards. And there was a question also confirming about the cable in the sled, whether it's for PCIe and sideband signals. That is correct. The cable between the baseboard and the Delta Lake is both for PCIe and sideband management signals, and the backplane is for the power. The backplane connection to the power vertical PDB is for power.
There's another question about
Go for it.
The configuration with 4 compute cards each with a flash card. Is it possible to replace flash card with an accelerator card? It is possible to do that as long as they're form factor compatible and the software supports that.
There's also a question about whether the M.2 flash cards require a new heatsink design compared to Yosemite v2. The ones on the Delta Lake that are M.2 onboard, we use similar heatsink designs, but the integrated heatsink of how we assemble them is slightly different for Yosemite v3. So there's slight adjustments, but the heatsink design is pretty similar to Yosemite v2.
There's a question on the fan form factor. The fans are they're same as the Yosemite v2. Yeah, we should. I don't have that exact information on the form factor for the fan. We can share that in the spec that will be released soon. Unless Ryan, if you know the form factor.
Yeah, I know we have 2 forms of fan options. I don't think I have the millimeters exactly on the top of my head. We could possibly send that by the chat. But we do have a different density of fans, just for reference. Like in the Yosemite v2, it was 2 fans per assembly and 1 assembly per sled. In Yosemite v3 now, it's 2 modules with 2 fans each. So there is it's a different fan topology with higher thermal capabilities.
There's a question on the server with accelerator with the PCIe switch. Is the switch in the GPv3? Yes, the GPv3 will have the switch. There's
also a question about the Yeah, go for it.
Okay,
Yeah,
go ahead.
spec.
The Delta Lake spec, it will be released soon in a couple of months. And once it is released, it will be available on the OCP website. There's also the Delta Lake presentation coming up next.
And there's a question about can the 70v3 sled support E1.S? There is expansion cards that are being investigated and worked on to support E1.S flash form factors as well. That's not part of this session here, but that is also a possible feature form factor that Yosemite v3 can support. I think for now, I know there's a question about how many E1.S SSDs can fit into a sled. I think we haven't exposed the expansion card designs for those. We won't answer that just right yet. The shared NIC interface as well, a question about the PCIe option that is PCI Gen 3, 4 lanes from the Delta Lake card. For the Delta Lake card, at least we're not currently planning PCI Gen 4 support based on the current server design, but we do intend the 70v3 to be capable of up to PCI Gen 4 link speeds with potential other server card options that can go in the sled.
The question about if Facebook was thinking about the 2S systems. Yosemite v3 platform is designed to be very dense and compute intensive. So from a thermal perspective, adding more than one CPU wouldn't be possible at the rack density we are looking at.
And there's a question just whether introducing YV3 is because of 48 volt support and modular. Definitely one of the reasons is around the modular solution and the form factor that's possible with this type of larger space, higher power and thermal capabilities, and more config options for different system configurations, considering storage and acceleration options. Those are some key driving factors for Yosemite v3.
I believe that's all we have for the questions.
I think so. Thank you very much for everyone who joined. Really appreciate everyone's attention and look forward to talking about this in future. And feel free to reach out to myself or Kieran separately if you'd like to discuss or have any other follow-up questions that we can discuss about Yosemite v3. Thank you very much.